Hello everyone, welcome to the platform Unacademy, India's largest online learning platform where you are preparing for your aspired examinations, that is the GATE and the ESE. Before moving into the our lecture discussions, I want to give a brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University and I have a qualified GATE twice. And I'm the author and co-author of various research papers publication of national and international journal of repute. I have also worked at CSIR's Institute of Mining and Fuel Research. And you can follow me here at the unacademy.com at the rate of v.kesar, where I am teaching the strength of material full courses there, right? That is totally free for the GATE 2021. So you can definitely go and follow me there and check out my videos or your lectures, what I have taught. Now, basically, in this session, we are going to see the numericals, whatever the numericals that are very much important, as well as a little bit theoretical concepts. We are going to tackle related to the ECM process. Before starting the our discussions, if you have not downloaded the Unacademy Learning app, then please download the Unacademy Learning app from the Play Store. Go and search in the Play Store Unacademy Learning app and then download it. After downloading, just sign in with your basic credentials, and then you can always go for the attend the free classes. There is a paid classes and there is a free classes. So basically, in the free classes, that is known as special class. Is special class. So basically in the special class I teaches for the strength of material, that is at 10 a.m. daily. Fine. So you can go and check out my videos, and these are totally free of cost. And this is just like a YouTube. Fine. So there is nothing so much worry about it. And there is a paid. So in this paid part, you will be able to access all the videos once you are enrolling or once you are subscribing for the different subscription packages after that. Fine. So what are the benefits that you are getting here? So basically the classes are free of cost. Daily classes are there, tests and quizzes you can give, and the courses are structured in nature. These are the benefits. As well as if you are talking about the plus subscription, so in the plus subscription, entire syllabus is covered. Okay, so entire syllabus will be covered there. Entire syllabus will be covered. So there is a totally, it is totally worth it. 100% syllabus completion would be there. Classes are daily live. So when the live classes would be there, definitely you have a chance with your interact with your educator, and definitely after the interaction, whenever you will be having any doubts or the issues would be there, definitely you can get back to them and they will be resolving your issues and the doubt at the same time. Courses are very much structured in nature, that is totally like it, they are designed in such a manner that it is like is एक ही बार में आपके दिमाग में बस घुस जाए। तो इसी तरह से कोर्सेज जो है बहुत ही अच्छी तरीके से डिजाइन की जाती है। टेस्ट एंड क्विजेज you can give, and the unlimited access of the course content materials are definitely there. There is another subscription package that is known as the iconic subscription. In this you will be getting all the benefits of the plus, and apart from that there is another thing that you are getting, that is the personal coach. So you can choose any of your educator to be your personal coach, and that educator is liable to help you throughout the preparation of GATE and ESE. Next is the study tracker. So basically in this study tracker, your study will be tracked. For example, if you are giving the mock test or the practice test, what exactly is the mistakes that you are committing each and every time? What is the area that needs to be improved to get the good rank in GATE? So these things would be taken care by the educator. Definitely the study tracker would be there. So your each and every aspects and parameters will be tested and analyzed, and after that you will be told that you need to improve in these and these area, so that your marks and rank will be boosted enough in the upcoming GATE examinations. You will be having lots and lots of the question and answer for the practices purposes. For example, that you will be having the mock paper, you will be having the practice paper, you will be having a lot of things. So definitely the intention is there that you may not have to refer any other course or the sources for the practice purposes. So each and everything would be provided in this iconic subscription. Apart from that, you will also having the doubt clearing sessions are also there, है ना? तो बहुत कुछ चीजें हैं इन चीजें में, in iconic subscription में. You can definitely go and check out those things. So basically these are the benefits in the iconic subscription. For the plus is the extra benefit that you are getting. Definitely you can go and check out these things. And definitely subscribing to any of the courses, you will be able to learn from the India's top educators also. And for the GATE and ESE, there are a lot of batches which has already been started for the mechanical, civil, electrical, electronics, production, industrial, and so on and so forth. So definitely you can go and check out in the website. So there are a lot of batches which I have talking about. What are the batches? So batches are rank booster batches. For example, for the ESE prelims, for the mechanical, for each and every branches, these batches are there. For electrical, for EC, for civil, mechanical. So definitely you can go and suggest to your friends also that these batches have already been started. You can go and check out those things if you really want to enroll in these batches. Suppose the batches are also there for the 90 days, GATE preparation in 90 days, GATE completion is 3 months, 2 months. Rapid revision batches are also there. Rapid revision batches for the mechanical, civil, electrical, electronics, for these things are also there for each and every branches. For example, the doubt clearing sessions are also there, right? Doubt clearing sessions batches are also there. So a lot of batches has already been started in the month of October and the November. So definitely you can go and check out these batches. If you really want to enroll in these batches, enroll it with my code, that is the SIR VK to get the maximum discount in these plans. Definitely if you're going to subscribe for the plus subscription, these are the amounts. For the 1 month it is 5,500, for a 3 months it is 13,750, for a 12 months it is 30,250. And these are the new plans, that is the 18 months and the 24 months plan. Definitely you can go for these plans if you are in second or a third year, for the proper understanding of the concerned subjects. And if you don't have any time, that means like you are preparing for a GATE 2021, definitely you can go and purchase these plans for the 1 month and for 3 months for the course completions of your each and everything. And for each and every plans, if you're going to subscribe, use my code SIRVK for getting the 10% off, as well as to enroll in my personal mentorship program. Suppose that if you're going for the 12 months plan, that will be costing around 30,250, but again that will be discounted amount would be 27,225 if you are going for the my code. Next is the iconic subscription. If you are going for the iconic subscription, these are the amounts for the iconic subscription. But again, if you are using my code SIRVK, then you will be getting a 10% off, and as well as you are automatically subscribing to my personalized mentorship program for the same. Okay, so let's start our discussions of today's session. So basically in the earlier session, we have seen some of the formulas related to the ECM processes. Fine. So we have seen that mass is equal to ZIT. Mass is equal to ZIT. Where what is the Z? Z is given by this formula, that is the gram equivalent weight of the material by Faraday's constant. Clear? So this is the formula that you always keep remember, my dear friend. Always and always remember these formulas. These formulas are very much important while solving the ECM numericals. And if you are remembering these formulas, believe me, each and every numericals will be solved by you without any hustle. So just remember that Z is equal to E by F, where what is the E? E is the gram equivalent weight of the material. And what is the F? F is the Faraday's constant. Now this E is also known as A by V. A by V. What is this A by V? A means weight, atomic weight of the material, and V is the valency, right? So when you are substituting this E is equal to A by V, definitely you are getting that Z is E by F IT, and definitely when you are replacing this E with the A by V, you are getting these relations. So remember these relations. Remember these relations. If you are remembering these relations, my dear friend, you will be able to solve each and every numericals related to the ECM processes. Fine. And even if you cannot remember it, definitely if you what I have explained you how these formulas are coming, if these things are in your mind, definitely you will be understanding these things. Now see, these things are also important, that is q is equal to it, right? Next thing, we have seen that the units, right, always important, units is very much important. So mass unit is in gram and t is in seconds, fine. These things you just remember. So this is the, in the nutshell, I have explained that this is the most important formula. Just you have to remember this thing, clear? Next is, if you want to find the MRR, that is the material removal rate in gram per second, fine. So this is the formula, that is MRR is equal to IA by FV in gram per second, clear? Now see here, this A by V, always remember this A by V is what? E. E, clear? This A by V is what? E. Now if you want to find the MRR in mm cube per second, so how you can find it? So basically you can find it, the MRR in gram per second is this, by this formula, by this formula, and the MRR in cube per second by this formula. So basically the difference is where is the difference? Difference is that in this formula, the density is the new thing, right? So in this, density is used, and by density is just divided, right? So this is all, the formula is valid for the pure material. We have seen that these formulas are valid for the pure material, right? Also we have seen that what is the specific material removal rate, right? We have also seen what is the specific material removal rate. Yeah, we have also seen that what is the specific material removal rate, that is these things, fine. That is these things, this formula, clear? That is E by F rho. And what is the J? J is the current density, that is denoted by I by A, fine. Now we have also seen that is for the means like for the electrode feed rate, this is MRR, specific MRR, right? Specific MRR into J, specific MRR into J. This is the electrode feed rate. This is how the it is defined. Now try to understand this by the another formula, that is this. See here, that you know that J is what? V by rho L, isn't it? J is what? V by rho L. We have explained these things, how J is coming as V by rho L. Now see here, you can put it here in the electrode feed rate equation. You can put it here, that electrode feed rate is equal to specific MRR into the current density. Now this current density is replaced by V by rho L, isn't it? It is replaced by V by rho L. So just remember this also, fine. Just remember this also, that this is nothing but MRR, specific MRR into V by rho L, clear? So this is very much important formula. Electrode feed rate is given by this. Fine. So I hope these things are clear to you. If these things are in your mind, definitely you will be able to understand the things. Now we have talked also about, in the earlier class we have talked about the alloys. For the alloys, how you can find the rho equivalent and the equivalent. So definitely, if this is the two types of alloys are there, definitely two types of metals are mixed in the alloy. But definitely, suppose you know the concentration, fine, how much percentage is there. So by using this formula, you can find the concentrations, you can find the rho equivalent, fine. Don't worry, we are going to apply all the formulas whatever I have discussed to you in our numericals aspects, and then each and everything would be clear and crystal, fine. Crystal clear ho jayega sab kuch aapka. Now we have also seen that if we want to find the equivalent, how we can find the equivalent, by using this formula, clear? So I hope these things are clear to you. So let's start our discussions of this analogy. Let's start our discussions, fine. So the first question here you can see here. So what I would recommend you, so just pause the video and try to answer this question on your own, and then match your answers with my answers. Fine. Now see here, this ISRO 2009 problem was there. The machining process in which the workpiece is dissolved into an electrolyte solution is called. Now see here, we have explicitly seen that this word electrolyte, my dear friend, this word electrolyte only and only comes in case of a ECM process, which is given in this option. Fine, that is ultrasonic, no. EDM, no. Laser, no. Even if you have not studied these things, don't worry about it. The only option is correct, which is the electrochemical machining, because in this machining processes we are using electrolyte, which helps in conduction of the electric current, and hence the machining processes takes place. Fine. Next question is there, that is the ISRO 2011 question. Commercial ECM is carried out at a combination of. Now see here, if you could remember what I have told you, that basically in that a very high amount of current is given and a very low amount of voltage is given. So basically the ECM is a low voltage and high current process. Okay, low voltage and high current process. These things we have seen. Now see, the next problem is here, the GATE 2014 problem is there, the principle of material removal in electrochemical machining processes. So here, so in ECM we have seen that it is based upon what? It is based upon the Faraday's laws, isn't it? We have seen that based upon the Faraday's laws. See here, the very first slide, what I have explained to you, my dear friend, that is the principle. Principle is what? So basically it is based on the Faraday's laws of electrolysis. Clear? So the ECM process is based upon the Faraday's laws of electrolysis. Clear? Now, so these questions are clear to you. Let's see here. Now let's see a very good question which has been asked in GATE 2008. Let's try to solve this question, and then uh, we are going to see these things also. So I would again recommend you pause this video and then try to solve this question, and then match your answers with my answers. Then in that way your concepts would be very much clear. Fine. Now see, in this question it has been told, in an electrochemical machining process, that is the operation, a square hole of dimension 5 mm cross 5 mm is drilled in a block of copper. Fine. So this is a what is the meaning? That is that there is a copper workpiece is there, and in that copper workpiece you need to see here, there is a copper workpiece. Fine. Suppose, just a minute, suppose this is a copper workpiece. So suppose this is a copper workpiece. In this copper workpiece, basically in this question it has been given to form a square hole of 5 cross 5 mm. So basically in this you need to make a square hole of 5 cross 5 mm, isn't it? So there is a square hole in here, and whose dimension is what? 5 cross. Now see here, the current used in this process is 5000 amp. So let me write it here, that current used is 5000 amp. The atomic weight of the copper, so basically the atomic weight of the copper, this is the copper. Fine. So copper is 63. Clear? So Cu is given as 63. The weight, atomic weight of copper, so let me write it here, that is A of Cu is 63. Valency of dissolution is 1, so you can write V is equal to 1. Faraday's constant is 96500 coulomb, so definitely F is what? 96500 coulomb. Now the material removal in gram per second. So what is the formula for the material removal in the gram per second? Just remember the formula. So I have explained it. The MRR will be is equal to AI by BF, है ना? ये होता है हमारा AI by BF, that is C. बेसिकली अगर याद आपको आ जाए, EI by F, है ना? यही हमारा होता था MRR in gram per seconds. This is the in gram per second. Clear? So in this question, each and everything is mentioned here. That is the E. So A is what? 63. Clear. So A is given as 63. Put it here, 63. What is the current? Current is given as the 5000. Put it here. That is the 5000. What is the valence? Valence is given as 1. Yes, it is given as 1. What is the Faraday constant? 96500. Put it here, 96500. So in this way, you can find the MRR, which will be coming to be around 3.26 gram per second. So what is the lesson from here, what we can get? So 3.26 is correct answer. So definitely you can write in option B would be the correct answer. Now what is the outcome? What is the key takeaway point from here? That remember, my dear friend, again I am telling that if you want to find the MRR, if you want to find the MRR in in gram per second, then these are the formula. Fine. Okay. Now let us try to move to the next problem. Now, this is the again next problem that has been asked in GATE 2011. The question states that while removing material, while removing material from the iron, okay, so you are removing a material. So suppose there is a workpiece which is made of the iron, fine, and in this iron you are removing the material from. Now, what is the atomic weight? So atomic weight of the iron is given as 56. Okay, so let me write it here. So A is given, A of Fe, that is the iron, is given as 56. Now valency is given as 2. Density of that material is given as 7.8 gram per centimeter cube. Clear? By electrochemical machining process, find a material removal of 2 centimeter cube per minute. So there is a material removal rate which is given as 2 centimeter per minute is desired. So basically these are the things that has been given to you. Now they are asking that you require so a MRR of 2 cc per minute, that is the 2 centimeter cube per minute is desired. So for these kind of conditions, what should be the current? What should be the current to achieve these kind of MRR? So how you can achieve that thing? So first of all, try to understand that what is this MRR? This is in centimeter cube per second. Now we have seen that either we have seen that the MRR in the gram per second, or we have seen in the cube per second, isn't it? So basically the point is that, what is the point? Point is that we have seen in the per second part, right, not in the minute. So basically we will try to find it. So MRR, so basically the MRR is given by, see here we have seen that EI by rho F, EI by rho F, we have seen this. So this will be in, this will be in, so how you can write this E? How you can write this E? E can be written as A by V, I by rho F, fine, and this will be in centimeter cube per second. So basically what is this MRR? See here, this is 2 by 60. If you will multiply by the 60, if you will divide by the 60, then you will be getting centimeter cube per second, fine. So this would be centimeter cube per. Now what is the A? So A is given as 56, isn't it? Just write it here, 56. I will be what? What is the I? Current which is given. So you need to find the current. Fine. What is the valency? That is the 2. Put it here. What is the density? It is 7.8 gram per centimeter cube. So 7.8 gram per centimeter. Now definitely you can multiply it by the Faraday's constant. What is the Faraday's constant which is mentioned here? So the so see here in this question the Faraday's constant has not been mentioned, so you just have to remember the formula. That is the Faraday's constant is actually is equal to 96500. Okay, so put it here, 96500. Now you don't need to worry about it the units, because units is in very much agreement, because the 7.8 is in gram per centimeter cube, in gram per centimeter cube. So centimeter cube will cancelled out, and definitely with these calculations, when you will be performing the calculation, you will be getting the current, that is the I, is equal to 896.07. So the answer would be option A. Clear? So I hope you have understood these things. Okay, and you, these things, these problems are very much easy, fine, very much easy. Now just here, what is the key takeaway point here? So in earlier question, the question was asked from gram per second, right? Gram per second. Now in this everything is same, but the difference is that the centimeter cube per second is there. There is a volume that is here. So just remember these formulas. Okay, let's try to see this another question that has been asked at GATE 2013. What is this question? Again, I'm suggesting please pause the video and try to solve this question and then try to match your answers with my answer. Now see, this is a question which has been asked in GATE 2013. During the electrochemical machining, that is the ECM, of the iron, atomic weight is given as 56, valence is given as 2. At current of 1000 ampere with 90% current efficiency, the material removal rate was observed to be 0.26 gram per second. Lot of data has been given. Try to hold on. अभी थोड़ा रुक जाए. Lot of data has been given. Hold on. Now छोटे छोटे करके चीजों को एनालाइज करें. चलिए देखते हैं यहाँ पे क्या बोला क्या गया. छोटे छोटे करके भी तोड़ते हैं इसको. चीजों में क्या बोला गया कि ड्यूरिंग एन ईसीएम प्रोसेस, फाइन ईसीएम प्रोसेस है एक, उसमें क्या बोला गया, आयरन है, ठीक है, आयरन है. What is the atomic weight? That is the 56. Fine. So I will just write it here that there is an iron. Okay. And for that, atomic weight is given as, that is the atomic weight for iron is given as 56. Clear? Okay. Now valency is given as 2. Okay. I will write valency is given as 2. No problem. At a current of 1000 ampere. Fine. So current is given as 1000 ampere with 90% current efficiency. Now try to understand, my dear friend. That means what is being told here, that you have been given a 1000 ampere, and out of this 1000 ampere only 90% is the current that you will be getting efficiently, isn't it? 90% current efficiency का मतलब क्या कि मैंने आपको जितना दिया है उसमें से सिर्फ 90% पार्ट ही आपका efficiently आपके पास पहुंचेगा, है ना? So if that is the case, what is the meaning? That if there is a 90% current efficiency, if there is a 90% current efficiency, then what we can say, basically the current will be what, 0.9 into 1000 ampere, isn't it? So this will be your current, this will be your current, है ना? अच्छा, चलिए, now try to see here. The material removal rate was observed to be 0.26 gram per second. So if this is the condition, then material removal rate is given as 0.26 gram per. ठीक है? I hope you have understood these things. Fine. Now, so if that is the case, let us try to see the another aspect. If titanium, whose atomic weight is this, valence is this, is machined with the ECM process of current of 2000 ampere with 90% current efficiency, the expected MRR for this will be what? So basically they are asking about the MRR for the second case. How you can find it? First of all, try to find the density for the first case. How you can find the density for the first case? See here. See here. So basically how you can find it, so basically what is the MRR? MRR is given by A by V into I by F, है ना? These things we have seen. Now what is the what is the values that we have seen? We have seen that A is equal to 56, V is equal to 2, current is equal to 0.9 thousand. So just put it here. And what is the MRR? That is the 0.26. Put it here. So MRR is 0.26. What is the A? A is given as 56, right? This is 56. A is 56, V is 2. Put it here. 56, V is 2. What is the current? Current is given as 0.9 into 1000. 0.9 into 1000 by Faraday constant. What is the Faraday constant? So it is not given in the question. So basically you remember the F is nothing but 96500. Okay, that is the coulomb per mole. Now put it here, 96500 into what is the density. Now see here, you don't know the density, isn't it? You don't know the density. So density you need to find it from here. So from here, when you will be understanding, you will be finding the density that is coming to be around 0.9956. Okay, 0.9956. Now see here, Now see here, you can very much understand that the unit is what? Ampere. Clear? So this is in gram per seconds. Fine. Definitely you are getting density. You're getting the density here. Fine. Now try to implement in the second case. So basically in the second case, what is being told? So basically in the second place it has been told that if titanium whose atomic weight is 48, valence is 3 is given, and current is what? So let me write it here. So if that is the second case, what you can write? MRR will be what? Again the same thing, that is the A by V I by F rho, isn't it? Where rho is the density. Fine. So 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 see here, this you can write like gram per centimeter. Don't worry about the units because units are same, but even if you should be very much aware and it's like everything should be clear to you, units में क्या दिक्कत नहीं होना चाहिए, ठीक है? So now now see here, so if the titanium is given, that is the weight is 48. Fine, so put it here, that is the weight is 48. So let me write like MRR. So what is the A is 48. What is its valency? Its valency is 3. Its valency is 3. What is the current? What is the current? Current value is what? Current value is, that is 2000. You are giving the 2000 ampere, but it is again having the with the 90% current efficiency. So what I can write, that 2000 ampere you are giving, but it is actually 90% efficient. So you are getting these kind of current. है ना? So what is the F? Again it is 96500. And what is the density? That is the 0.995. Okay, so this is the thing, and now you will be calculating the MRR. So MRR would be coming to around 0.30 gram per, ठीक है? तो MRR की वैल्यू जो आएगी वो होगी 0.3 gram per second. So from here you can see the option C would be the correct answer. Clear? So this is how you can solve the questions, and basically believe me, the questions that are asked from this ECM is very much easy once you have understood the concepts, understood the formulas, and then there is nothing. There is another thing, that is the practice application part, and just we're done with that. Okay, so now try to see this question. This is a question which has been asked in GATE 2011, that is in PI paper. And this question, what is being told? Try to firstly understand and comprehend this problem. So basically, there is an electrochemical machining is performed to remove material from iron surface. Fine. So there is a workpiece is what? Iron. Fine. So एक workpiece है जिसका surface क्या है? Iron का. Clear? Now you want to make a cavity, that is the 20 mm cross 20 mm. Fine. ठीक है, तो इस तरह का कुछ आपका कैविटी आपको बनाना है. इंटर इलेक्ट्रोड गैप इज गिवन एज 0.2 mm. ठीक है, तो सपोज कर लें कि आपको कोई कैविटी बनानी है वर्क पीस में. दिस वर्क पीस इज लाइक दिस इज योर वर्क पीस, एंड इन दिस वर्क पीस basically you want to make a cavity of 20 cross 20. Fine, that's not a problem at all. We can handle this 20 cross 20 dimensions cavity. Now what is there? You have a tool, isn't it? So this is a tool, and this tool is connected with the negative terminal, and this workpiece is connected with the positive terminal, isn't it? Now see what is happening. It is, they are having inter electrode gap, that is 0.2 mm. So basically this is the distance between the workpiece and the tool, that is this is the L is given as 0.2 mm, isn't it? तो L की वैल्यू जो है, मतलब गैप है ना उसके बीच का, गैप की वैल्यू गिवन है 0.2 mm. अभी आप इसको 12 वोल्ट की मतलब वोल्टेज आप सप्लाई कर रहे हैं. What you can say here, the voltage is given to you, that is the V, this is the L. Now specific resistivity of the electrolyte, that means what? That is the rho. Rho is given as 2 ohm per centimeter. Now atomic weight of iron is given as 55.85. Valency, that means what, A is given, valency, that means V is given, Faraday's constant, that is the F is given. So remember, we know that 96500 is the Faraday's constant, but here in the question it has been told to use 96540. So don't use 96500, otherwise your answers will be wrong. So if अगर क्वेश्चंस में आपको जो डेटा दिया जाता है ना, उसी डेटा को यूज करना है. Clear? Now try to implement it. So you need to find the material removal rate. Now how you can find the material removal rate, my dear friend? Try to understand here that MRR is given by I E by F, isn't it? Now we also know that E is what, A by V. Yes or no? So IA by FV. This is the MRR that we are going to get here. Now see here. You know the current. Do you know the current? Current value you आप जानते हैं क्या यहाँ से? Oh, current value is not known to me. Fine. Do you know the A value? Yes, I know the A value. Okay, this is known to you. Do you know the F Faraday's value? Okay, I know. Do you know the valency? Yes, you know. So the problem in this, that is, you don't know the current value. So first of all, we have to go and find out the current value. And once we can find the current value, we will be able to solve this problem. Now, how you can find the current value? So what you can see here, so due to this, there is a gap. There is a resistance which is actually coming in this picture. So can you say that resistance that is acting here is given by rho into L by A, isn't it? Now see here. So resistance that is actually acting in this case, basically see this case. So basically the resistance that is actually acting in this case, that is rho. What is the rho? Rho will be 2 ohm centimeter. Fine. So I can write here 2 ohm centimeter. So this is what into L. What is the L? L is the spark, that is the gap, electrode gap, that is 0.2 mm, isn't it? Put it here, that is 0.2 mm. And what is the A means that is the area of machined part, right? So kitna machining hua yahan pe? So that is, see, that is the 20 cross 20, that is this part, है ना? ये part आपका machine हुआ है. तो क्या आप कह सकते हैं कि इसका जो ये जो टूल का जो एरिया होगा, टूल का एरिया भी तो उतना ही होगा ना, है ना? टूल का एरिया भी उतना ही होगा. दैट इज 20 क्रॉस 20. You can write here 20 cross 20 mm square. So by this, see here, this is the centimeter, this is in centimeter. Fine, just convert it in the centimeter. So this will be this is in centimeter, this is in mm. Just multiply it by 10 and just convert it. Fine. After the conversion, you will be getting as 210.2 by 20 cross 20. Fine. Now you are getting that value, resistance value is 1 by 100 ohm. Is nothing but 0.01. Now what is the I? What is I? Can we say that I is equal to V by R? Yes or no? Now see, what is the V? What is the voltage that is being applied? Is it 20 volt? It is 12 volt. Yes, it is 12 volt. Put it here. 12 by resistance is what? 0.01. 0.01. So when you will be putting these values, you will be getting the current as 1200 amp. Wow. Now we are done with the current. Now once we know the current value, it is very much easy. You can put it in this formula and you are done with that, isn't it? So just try to find it here. So MRR, material removal rate, is given by IA by FV. Now what is the IA? See here, I is 1200. A means atomic weight. Atomic weight is given as 55.85. Put it here, that is 55. What is the Faraday constant that is given in the question? That is 96540. That is 96540. And what is the valency? V. It is 2. Clear? Now once you are plugging these figure, definitely you will be able to get the value, MRR value, as 0.347 gram per. So you are done with this question. See how much easy question was there, but the problem is that if you cannot visualize the problem, that what exactly is happening, right? So visualization is very much important. Visualization is very much important, and if you could visualize the things, definitely then your problem solving skills would be improved and you are able to solve the problems in a very easy manner. Fine. चलिए, तो आशा करते हैं कि क्वेश्चंस आपको बहुत अच्छी तरह समझ में आ रहा होगा और कोई डाउट नहीं होगा. बट इवन इफ यू विल बी फेसिंग एनी काइंड ऑफ डाउट, डेफिनेटली यू कैन रीच आउट टू मी. आई विल ट्राई माय लेवल बेस्ट टू make you understand the things that I have already taught to. Clear? Okay. Now see here. Let's talk to the another problem, that is the GATE 2002 problem. Is again pause the video and try to solve this question, and after that you can verify these questions with answers with my solutions. Now see what is being told here. So estimate the MRR, so in cc per second, that is the centimeter cube per second, of an alloy. So this is a problem of the alloy. So alloy containing 80% कोबाल्ट, 62% निकेल, 20% क्रोमियम, है ना. तो आप समझ लें कि एक एलॉय है जिसमें कोबाल्ट है, निकेल है और क्रोमियम है, और उसकी मात्रा दी गई है कि कोबाल्ट आपका 18% है, निकल 62% है और क्रोमियम 20% है. ठीक है. सो बेसिकली इन दिस प्रॉब्लम इट हैज बीन टोल्ड दैट दिस इज एन एलॉय. There is an alloy. In this alloy, cobalt is there, nickel is there, chromium is there, and LNC is there. See, there is a printing mistakes are there. Fine, no problem. So alloy is given. So in this, these things are given to you, and the percentage. Let me write the percentage here itself so that we will be having no problem. Now in the percentage, cobalt is given as 18%. Clear. So 18% cobalt is there, 62% nickel is there. Fine, and the 20% chromium. Now, during the ECM, current is given as 500 amperes. So you can always write that current is 500 amperes, isn't it? Now, the density of the alloy. So alloy की density given है. आपको इस क्वेश्चन में alloy की density नहीं निकालनी है ना? Density आपकी given है alloy की. So density of alloy is given as 8.28 gram per centimeter cube. The following data are available. Now you need to estimate the MRR. So how you can find the MRR? First of all, always remember that MRR for the alloy, you have seen that this is nothing but E equivalent by I into I by F into P. Clear? ये जो है F into रो, F into रो. ठीक है. ये जो है फॉर्मूला हमने देखा है, दैट इज द रो इज रो इक्विवेलेंट, है ना. अभी आप समझे ये ई इक्विवेलेंट क्या है. ये ई इक्विवेलेंट क्या है? नॉर्मल केसेस में हम ये जो ई जानते हैं, ये ई क्या है? ए बाई वी है, where A is what? Atomic weight of the material and V is what? Valency of the material, isn't it? तो यहाँ पर percentage wise given है चीजें. तो what you can say here, I have given you the formula. You remember this formula? Just a minute, I'll show you these things. So if you have to find the E equivalent, that is the E equivalent, how you can find it? Summation of xi vi by ai, and you divided by, you just do it and you will be getting the answer like this, है ना. ये आंसर आपको इस तरह से मिल जाएगा. ठीक है. तो चलिए जरा देखते हैं, सॉल्व करने की कोशिश करते हैं प्रॉब्लम को. So what you can write here, that E equivalent basically 1 by E equivalent is equal to summation of xi ai vi, right? It is vi by ai. ठीक है. ये सब चीजें हमने देखा है. Now see, if you could multiply this by 100, then only you can write xi is what? 18%, 12%, 20%, like that. And if you don't want to write this in the percentage, then definitely you can write like that. How you can get the answer? 1 by E equivalent. So you can write it here, that is the x1 v1 by a1 plus x2 v2 by a2 प्लस x3v3/a3। अच्छा देखते हैं यहाँ पे 1 बाई इक्विवेलेंट जो है वो x1 v1 a1 क्या है, तो x1 क्या है, देखिए x1 इज 18% है इसका, तो व्हाट आई कैन राइट हियर दैट x1 x विल बी 0.18, x2 will be what 0.62 एंड दिस इज 0.20 एंड इसको आप ऐड करते हैं तो ये आपका 1 आ जाएगा, ठीक है। सो ये हो गया आपका वैल्यूज गिवन है, सो दिस इज 0.18, पुट इट हियर दैट इज द 0.18 into what is the valency given, so valency is given as 2, so 0.18 into 2 divided by the a, that is 58.93 है ना, so you can write it 0.18 into 2 divided by 58.93, summation is what is the x2, so x2 is given as this 0.62 into 2 by 58.71 है ना, so write it here, that is 0.62 into valency is 2 by 58.71 plus of x3 v3 by a3, what is the x3, x3 क्या है 0.2 है क्या, v3 क्या है 6 है, वैलेंसी 6 है, and the a3 that is 51.9, here let me write it here, that is 0.2 into 6 by 51.99. Now if you will be solving from here, so now what we have seen that this is the 1 by E equivalent. Now from here when you will be calculating, you will be getting that 1 by E equivalent to be, basically you are getting this to be around 5.03 into 10 to the power minus of 2, from which E equivalent would be coming to be 19.8807. Now from here what you can understand how you can find the MRR, how you can find the MRR. So MRR will be basically, this is E equivalent into I by F into rho equivalent. So you can write here that E equivalent into I by F into rho equivalent. F. So from here you have found out E equivalent to be 19.8807 into current is what? Current is 500 ampere. See here the 500 ampere is given. So put it here, the 500 ampere by F. Faraday constant is what? 96500, which is given in the question, and rho equivalent means rho of the Ly, density of the Ly, that is 8.28, isn't it? So you can write it here 8.28, and from here you will be getting the MRR value as, so MRR value that you will be getting as 0.01244, isn't it? So this is the value that you are getting. Now you can always go to this as 1.24 into 10 to the power minus of 2 centimeter cube per. Now what is the answer? So this is the correct answer for this GATE 2002 problem. Okay, now see here, let's see this question. GATE 2008 problem is there. A researcher conducts electrochemical machining processes, that is in this the density is given as 6000 kg per meter cube of iron whose atomic weight is given as 56. Fine, and balance is 2. And there is another metal P. Fine. So what is the meaning? So there is an alloy. There is an alloy. This alloy is made of the two parts. That is the iron is there and the another metal, that is the P. Fine. Now see here. Now see here, in this the atomic weight of the iron is given as 56, valence is given as 2, and the metal P atomic weight is 24 and valence is given as 4. Faraday's constant is 96500, that is known to us, no problem. MRR is given 50 mm cube per second, clear. What is the current? Current is given as 2000 ampere. Percentage of metal P in the alloy is closest to, so you need to find the percentage of P in this alloy. क्लियर, इस alloy में percentage P की कितनी percentage है वो आप कैसे निकालेंगे? So first of all let me write the things. So what are the things that is given to you for the iron? For the iron, what is the atomic weight? Atomic weight for the iron is given as 56. valency for the iron is given as 2. Fine. Now for the another metal P, so let me write it like that, metal P. So for that, atomic weight of metal P is given as 24. 24. Valency is 4. Valency is 4. Now for this alloy, what is the density which is given? See, for this binary alloy, the density is given as 6000. So the point to be remembered is that density of this alloy is 6000 kg per meter cube. Fine, this is the density of the alloy that is given to me. Now how can I find the MRR? So before that let me just change it something. This is the density of alloy which is given to me. Let me change its value something like that. You can write it as 6 gram per centimeter cube. ठीक है, just इसको convert कर ले ताकि your calculations would be easy. Okay, so I have converted this kg per meter cube into gram per centimeter. Now see how you can find the in this question the MRR is given as 50 mm cube per second. Fine, so you can write it here, that is the MRR which is given as 50 mm cube per second. Now see 50 mm cube per second is given. I can write this as 50 into 10 to the power of minus 3, and we can convert it as a centimeter cube per second, isn't it? So this is the MRR that I have got in centimeter cube per second, and this is the LY, density of LY I have found out in 6 gram per centimeter cube. Now see here, I can write that MRR is nothing but EI by F rho, है ना? ये हम जानते हैं MRR for the binary alloys that we can write MRR is equal to EI by F rho. Now what is the MRR? So I know it is 50 10 to the power minus 3, है ना? 50 into 10 to the power minus of 3 into E. What is the current? See, current is given as in this question, the current is given as 2000 ampere, isn't it? Put it here. What is the Faraday constant? Faraday constant is given as nothing is given. Yes, it is given 96500. Put it here, 96500. And what is the density of the alloy that is given, my dear friend? So it is 6 gram per centimeter cube. Put it here, 6 gram per centimeter. Now from here you will be able to find the value of E, and that is coming to be around 14.475. ठीक है, E की वैल्यू जो हमें मिलती है वो है 14.475. Now see here, let the percentage of LY in this be X%. अगर इस LY में P की परसेंटेज अगर X है तो आयरन की परसेंटेज क्या हो जाएगी? It should be 100 minus X, isn't it? That would be the case. So what I can write here, let percentage of P in LY is X. So what you can write that 1 by E equivalent. See, this is the equivalent, right? 1 by E equivalent is nothing but 100 minus of X percentage. Fine, so this is in percentage divided by 100. So you want to find it in terms of, like, see here, if you want to make it in terms of percentage, so put it here, 100 would be there, like, into valency of iron by A of iron, fine, atomic weight of iron, plus X, that is the X is the LY, fine, तो P जो है वो उसका X percentage है, X into V of P by A of P, fine. Now you know these values, isn't it? You know these values, that 100 by E equivalent is equal to 100 minus of X. What is the valency of iron? Valency of iron is 2, A is 56, so valency it is 2, this is 56, plus what is the X, you don't know. What is the valency of P, metal P? That is the 4, and A is what, atomic weight is 24. You can write it here, that is the 4 by 24. Now when you will be solving these equations, from these equations you know that what is the E equivalent, put it here. Basically you know the E equivalent, that is the 14.475. So that is 14.475. That is to be coming around X value that is to be 24.48. So now what we can understand from here, that 24.48 was the answer, so which is closest to 25%, isn't it? Now the answer is option. Okay, so answer is option. So I hope you are understanding these things, and see, basic formula is same for each and everything. And I hope the cases for the binary cases what we have seen है ना, LY का cases में आपको बहुत ज़्यादा अंडरस्टैंडिंग क्लियर हो रहा होगा, ठीक है, क्योंकि LY ही थोड़ा सा डिफिकल्ट हो जाता है प्रॉब्लम सॉल्व करने में, बट जनरली फॉर द प्योर मेटल यू कैन वेरी इजीली सॉल्व द प्रॉब्लम्स. Now see, this is another problem that is being asked here. In a ECM operation, hole of dimension 3 cross 5 mm is drilled in a copper block. Fine. So एक क्या है, एक copper block है आपका. Suppose you have a copper block like that. So in this copper block, basically what you did, you actually made a hole of 3 cross 5 mm. Fine. So 3 cross 5 mm. So let me write like that. This is 3. This is 5. So you have basically made a hole, something like that, है ना, एक pocket type से आपने बनाया. Now in this the current is 8000 ampere, so you can write here the current is 8000 ampere. Fine, current 8000 ampere है. Atomic weight of copper is given as A of copper is given as 63. Balance of dissolution means what, B is given as 1, है ना, B is given as 1. Now you need to find F is given as 96500. Material removal rate in gram per second. So how you can find the MRR in gram per second? Very easy. Again remember कि हम ग्राम पर सेकंड में कैसे निकाल सकते हैं. So formula says that EI by F. Fine. What is the E? E is A by V into I by F. What is the A? A is 63. What is the valency? That is the 1. What is the current? That is the 8000. And what is the Faraday constant? That is the 96500. So from here you can find the MRR to be something which is around 5.2 gram per second. Now this is the answer that is going to be 5.2. So which is the correct answer? Option B is the correct answer. Clear? Let's move to the another problem. Fine, so let's move to the another problem. In this problem we need to calculate the MRR. Okay, so this is a M. You need to calculate the MRR. You need to calculate the MRR. Fine. You need to calculate the MRR and the electrode feed rate when copper is electrochemically machined under the following conditions when rho s is given. See, what is this rho s? The specific resistivity, isn't it? Specific resistivity. Tool gap, that is the L. Tool gap is L. Voltage is given as 18 volt. Atomic weight is given as 56. Current is given as this. Valence is given this. This is the density. So how you can find the MRR? So first of all, you need to find the MRR. What is the formula? The formula to find the MRR is EI by F rho. EI by F rho. How you can find it? So basically, what is the E? So E is replaced by A by V into I by F rho. Now you can write MRR. What is the A? A is given as 56. Put it here, 56. What is the current? Current is 500. And what is the valency? Valency is given as 2. Here. What is the Faraday constant? That is, Faraday constant is always, you need to remember, 96500. What is the density in this case? 7.8. Put it here, 7. Now from this, you will be getting MRR to be 0.0186 centimeter cube per. This is the value of MRR that you will be getting. Okay. Now you will be getting this MRR in centimeter cube per second. Now you need to find the electrode feed rate. How you can find the electrode feed rate? Electrode feed rate. Do you remember this formula of electrode feed rate, what I have explained to you, my dear friend? Let me show you the formula. Let me show you the formula. So basically, I have told you that electrode feed rate is nothing. It is actually this electrode feed rate is equal to MRR into J. MRR into J. And what is this J? J is the current density. And it is again replaced as MRRS. Means what? This is MRRS. Means what? Specific material removal rate into V by rho L. Into V by rho L. Now these things we know. We have seen these things. Now let us try to MRRS into V into L. So what is this? Specific MRR into V into rho L. Right? Just remember these things and let's try to implement these things in here. So here uh, you can write specific material removal rate into V by rho into L. What is the specific removal rate you have found out? So basically the specific removal rate is nothing but you know this, right? MRR by I is actually specific material removal rate, isn't it? So by doing this you can find it. So which is 0.0186 by current. What is the value of current? That is 500. Put it here, 500 into voltage is given as 18, density is given as 5, and the gap length is given as here. Voltage is 18 volt, density is basically the specific resistivity is given as 5. Fine. So specific resistivity is 5, and the gap. What is the gap? Gap is zero point 0.5. Put it here. Zero point 0.5 is the gap. Now this is the electrode feed rate. When you will be solving here, it will be coming around 0.0267 mm per second. Fine. Convert it in the mm. Convert it in the mm. Okay. This is coming to be around electrode feed. Fine. So this is the thing that we have tried to solve. So I hope you have understood these things, and if you have understood these things, do like this video, as well as remember my code. Remember my code is the SIRVK. Remember my code, that is the code is SIRVK, to get a 10% off in each of the subscription whatever you are taking it. And do not forget to like this channel, like this video if you have really enjoyed this video. So thank you so much for watching these videos, and definitely see you soon in the next video with a new concept and with a new numerical series. Till then, thank you so much. Take care.